In this lesson we're going to look at how to work out the equation of tangents to circles. So if the point of contact between a circle and radius is known, then the equation of the tangent can be found. The equation of this line here. There's three steps to this. Firstly, what you have to think about is the gradient of the radius. Because to get the gradient of the tangent, then the only way to do that is to use perpendicular gradients. There is no 2 points on the tangent line. We don't have one here, or 2 points. Therefore, we can't use delta y over delta x, we need to use perpendicular gradients. So the first task is to use the gradient of the radius. The reason for this is because we have the centre point and we have the point of contact, so you can work out the gradient using delta y, delta x. To get the gradient of the tangent, you flip this over and change the sign, because the gradient of the tangent times the gradient of the radius will equal -1. Lastly, once you've got the gradient of the tangent and the point of contact, you do your y take b equals mx take a. So these are the steps we're going to do in the next example. So it says show that 1, 3 lies in the circle, it gives the equation of the circle, and it says find the equation of the tangent at a. So to prove this point lies in the circle, we just basically have to show that 1, 3 satisfies the equation and it comes out to 0. So whenever you see an x, put a 1, and whenever you see a y, put a 3. So that's going to end up looking like this: 1 squared plus 3 squared plus 6 times 1 plus 2 times 3, take away 22. 1 squared is 1, 3 squared is 9, 6 1s are 6, 2 3s are 6, and take away 22. Now this comes to 10, 6 and 6, 22, take away 22 is 0. Restatement, therefore the point satisfies the equation and lies in the circle. Right, to find the equation of the tangent, the first thing we're trying to do is we're trying to find this, the gradient of the radius. We've got the point on the tangent, but we don't have the centre point. So that's what we need to do. We need to find the centre point of this circle. Use your formula sheet. 2g is 6, 2f is 2. G is 3, f is 1, so the centre point -3, -1. Now we have got the centre point, and we've got this point here, we can calculate the gradient of this line. So gradient using these 2 points is delta y over delta x. That's your centre point and point on the radius, 1, 3. On the equation, on the line. So delta y over delta x, 3 take away -1 and 1 take away -3 in the bottom. So that's come to 4 over 4, which is 1. So the gradient of the radius is 1, so that means the gradient of the tangent is -1, since the gradient of the tangent times the gradient of radius comes to -1. So now we've got the gradient of the tangent and we've got a point of contact, 1, 3. So we use these two things to do y take b equals mx take a. So y take 3 equals -1 x take 1. That becomes -x plus 1, and then add the 3 to get y equals -x plus 4. You can rearrange it all to equal 0, but this would be fine up here, adding the x and taking away the 4. Final statement, equation of the tangent at a is y plus x minus 4 equals 0.